Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan, and today I'm joined by Bill Wyatt. He's the CEO and he's the founder of Mountain Biochar. We're going to be talking about biochar. Interesting use of biomass for a number of different purposes. Red Mountain has a vision to decrease carbon footprints, to enrich soils, to strengthen communities worldwide. Big stuff. I really like part of their mission statement, contributing to climate resilience. Just delighted to have Bill Wyatt on the show today and to talk about biochar. Hey, Bill, welcome to the podcast. How are you today?
I'm doing great, Ted. Thank you for having me.
Well, I'm really excited to learn about biochar. I've already introduced you as the CEO and founder of Red Mountain Biochar. Before we get into it, where are you sitting today? I think you're in Texas. Am I right?
I am. I am east of Texas, in Greenville, Texas, about an hour east. In my background, I am a director of manufacturing for a $6 billion building materials company. I run a bunch of sawmills throughout the South. So I'm on the edge of the Pine Belt and travel extensively throughout probably 6 states and just about every southern pine mill that there is.
And Texas is home, right? You've been there. You're rooted in Texas. Well, tell us about biochar. I've been fascinated by the name biochar, by the topic. It's kind of mysterious. Explain to me what it is, and then I want to get into your story about how you got there. But what is biochar?
Biochar is a miraculous product that I've been very blessed to run across. From the actual product itself, you're taking waste and you're making a product that, at its highest core value, it is one of the true carbon sequestering materials on the planet, and the only one of two ways of sequestering carbon dioxide on the planet. So you take that as its primary function, and then on top of it, you can add the numerous benefits. And our primary function, because I'm agro-based, is back to the agro world, so to speak. And so when you put this product in the ground, from an application use, crop watering is reduced on average 35 to 40%. Crop yields are increased on average 40 to 60%. It reduces and or eliminates soil compaction, soil erosion. It enhances the microbiological activity and essentially because it provides tremendous surface area, which is part of its water storage capacity. It provides a platform for microbes to build healthy soils. In our process, we derive other verticals out of it. One of them is an oil called wood vinegar. So it, aside from the biochar, are two natural remedies. The wood vinegar is a substitute for fertilizers and pesticides. So this offers a really biological remedy instead of a chemical synthesized remedy to agricultural based products and problems. In a world where food production, water conservation, soil conservation, I'm from the lumber industry, so deforestation worldwide for agricultural use is a waste of forestry, which is a carbon sink in itself. And it's a misuse of resources that, in our industry, we're great stewards of our industry. We are so forward thinking on the management of our forests and the stewardship of it. This adds a layer to our ability to be good stewards of this resource in both the forests and at the residual side at the sawmill level.
Let me see if I can, let me dial you in, because you said an awful lot, which really helps me out. But you came from the lumbering business. You have sawmills. You end up with lots of sawdust and wood chips and scraps of wood.
Right.
You take that material away. It was a waste that you probably had to pay to cart off. You take that, you turn that into products. This wood vinegar that you mentioned,
right,
and the biochar, which has these amazing properties. Now, there's lots of other sources of biochar, right? Not just lumber products. What else? Where else does it come from? I think it comes from like sugarcane and other agricultural residues.
That's been part of the wildest ride as our brand has gained recognition, and we've started becoming an authority. What started as my core industry and a solution to my industry was the chips and sawdust
Yep.
waste, and on scale and magnitude that most people can't even fathom. But then we started getting other industries reaching to us just because we offer industrial scale production capacity. So literally, we're in everything in the U.S. from sugarcane bagasse to pistachios, almonds. We're in yellow pine chips and sawdust. We have a joint venture coming from Argentina. We'll be in biocoal. We're making biocoal out of hardwood chips.
So all this material is going to come to you in Texas, or are you actually creating plants?
So far in the U.S., we have 11 site locations up and coming, all the way from Florida all the way to California, and Texas all the way up through the Midwest. We're not really up into the north yet. I am being pulled up into the Northeast, up into the Maine area. So it looks like there's some evolving opportunities in that area. But yeah, if it's, we focused on agricultural biomass. So essentially, if it's an agricultural industrial crop, whether it's, we're working with one company on corn stover. So, whatever the agricultural waste is, there's a lot of change in industry right now. And California is probably, your state of California is probably an example. Open field burning, biomass burning from crop residuals is being banned. And it's being banned state after state. Your state has banned all open field crop burning.
Sort of like the slash and burn of the old days, I guess.
Yeah, and even from crop harvesting, right? So, and then the same thing's true in Florida. We're working with a huge sugarcane farm in Florida, 400,000 acres of sugarcane. And they have a mandate, no more open field burning when they're harvesting. And sugarcane is nothing but burning during the harvest. They burn off everything and then harvest the cane. So, these are real solutions or problems that have to have solutions. And, the solution we have takes that waste, creates an insanely valuable product. And I'm not talking about monetary. I'm talking about the performance characteristics of a product that truly has benefit across a range of applications that, from our standpoint, these are dire consequence issues. Clean water, feeding our burgeoning population globally, degradation of soils, these are all serious, serious problems. To have a product that is so wide ranging and other applications, biochar is only one application agriculturally. If you post-process it and put high temperature steam, you make activated carbon. And activated carbon is like the wonder drug of cleaning up water for water remediation.
So all these products cover. So let's talk about making biochar.
Sure.
And I think the word pyrolysis is a big part of this equation. And I really want to drill into how much energy it takes, because it sounds like you're taking all this biomass and, like you said, enormous scale. You're dealing with huge scale, but you're taking this biomass, you're putting it in some sort of a digester you can tell me about. You're heating it up, and then you're getting biochar, and sometimes you're getting oil, sometimes you're getting gases off of this.
Right.
Is that right? Is that what you're doing? You're heating it up?
We are, but from a processing efficiency. And I've been in processing my entire life. I'm a director of manufacturing for an enormous corporation. And this is probably the cleanest processing I've ever experienced in my life. And I'll explain the process as basic as I can. But we're taking a green residual, something that's cut from the harvest, not dried, not anything else, just green material coming in. So if you can imagine, there's two big rotary kilns. One is a dryer, and one is what we call our carbonizer, the pyrolyzing unit. The only difference between the two is the drying unit, the warm air passes through the dryer. And in the pyrolyzer, if you can imagine, that rotary kiln on the outside has a big box built around it that is brick lined, and we heat the box. So we're heating that rotary kiln from the outside of the kiln. And it has airlocks on it to prevent air coming in or escaping. So we're controlling the atmosphere. And those systems where the dryers are single pass, it enters at one end and it exits at the other.
Yeah.
The carbonizers are double pass, so it passes through, and it's about the resident time and temperature. So how long it's in there cooking at what temperature. And the whole objective is to burn off all the volatiles and get down to pure carbon. In that process, from when we initially start the process, we have what looks like two giant pistol grip hair dryers that plug into these refractories, and they're 1,500 kilocalories. So these are very, very high temp heaters. They heat the refractories up to the system temp, and this entire system is turned on, all the rotational parts, fans, everything, to get the entire system up to 650 degrees. Mm-hmm. Once it's up to temp, we start processing the raw feedstock into the dryer. And through the process of drying and entering the carbonizing, all of what's off-gassing in either gas or oils are either collected through exhaust manifolds or oil separators. And all of the synthetic gases are cycled and processed back into the refractories. They have their own burners that kick on. And at that point in time, about an hour and a half after the refractories have been warmed up and you start processing feedstock, the unit becomes self-sustaining. You turn off those piston grip warmers, and now it runs on its own accord. Now, it runs so efficiently that we pull electrical energy from the excess thermal heat we generate, and we also pull other energy products through SAF, the sustainable aviation fuels, and we also pull it through the oils through biodiesel. So we end up net positive on energy in terms of production. And everything we do is very clean and cyclical, so we have no emissions whatsoever.
That's really fantastic. Okay, now your goal here is to, as you said, to take this biomass material and to end up with pure carbon, right? Right. And that's the biochar, I take it.
It's not actually pure. It's more. Let me state it more specifically. It achieves its highest potential carbon within that feedstock. Yep. Because every feedstock only can achieve a certain percentage of carbon. I can't get to 100% pure. Yep. I can get to, if it says that, for example, yellow pine chips are 90%, I can achieve 90%, which would be considered 100% of what you can achieve, but it's not 100% carbon, right? It's 90% carbon. So for clarity, everything is kind of different on its carbon content potentiality. Right. And then it's the quality control of time and temperature to achieve its maximum potential.
Okay, so now let's bring this conversation towards greenhouse gases.
Sure.
So what would if you had a sugarcane field and you burned it in the old school, you would have tremendous smoke, and then you'd also have tremendous amounts of carbon dioxide, right? Being released.
Right.
Now you go into your dryer and your pyrolysis machine there, and you end up with a carbon or 90% pure carbon. What happens what happens? How is this better? How does that manage greenhouse gases?
Well, if you take that same pile, and I'll just give you an example.
Yeah.
I could take you to numerous sawmills throughout the South that have enormous piles of chips. 4,000, 5,000, 6,000 truckloads of chips piled up in piles. It looks like Chip Mountain. Yeah. Those piles, as they sit and deteriorate, are giving off CO2. They're not adding to any, or they're not helping like sequestering the carbon dioxide that they could reach in their potential.
Yeah, and they're giving off methane too, aren't they? If they get into anaerobic,
they're off gassing everything, and at the same time, it's providing no nutrient value to the soil, no water retention, no anything to the soil. So if that pile just sits there for eternity and rots, there is no value whatsoever. Now, it's sitting there in the pile because the mill can't monetize it to anything practical at all either. So do you monetize loss by moving the pile out at some impractical reasons just to get rid of a pile? Or now that there's a solution, do you work to figure out how to paradigm shift and work with somebody who's willing to footprint and alleviate or partner with you to alleviate these issues? And we're finding that most people are partnering. We're making very, very successful, globally successful partnerships with growers associations and tying it to governments and having the government subsidize us, much like they do with any other agricultural subsidy, to guarantee performance-based success. I don't want grants. We don't want money up front. We want performance-based success. So these are solutions that have been very, very, very successful. We have opportunities in numerous countries. We talked about feedstocks earlier. In India, we're working with bamboo and cotton. In different portions of Africa, South Africa, we're working with coconut. We're working with aquatic weed. We're working with cashew nuts. I mean, it's diverse agriculture, right?
Right.
And one of the things that at the scale that I'm accustomed to working here in the U.S., I'm responsible for 60 million feet of production a year across 4 sawmills. And there's not a lot of scale and production in this industry, the biochar industry. And what we're offering now is more to be that top-down footprint that people can repeat. They can come learn, and we can teach them and educate them. And we can cross it over in different agricultural products, whether it's cotton or cashews, and just teach and train the people, because the footprint's the same for us, right? So whether I build 20 plants here in the US or 20 plants globally and teach everybody, one's more impactful from the other, but at the end of the day, it's all impactful.
Now, Bill, when you back to the carbon and the biochar that you put in the soil as a soil amendment, I understand that at that point, carbon is basically locked in a form that it won't be re-released into the atmosphere for like 1,000 years. Is that right? Yes.
I would say probably the caveat is, depending on the quality of your biochar, yes. If you have high quality biochar, it locks it in for millennia. If there are lower forms of biochar that do it more on the centuries level. But, if you think about it, when you take a product that sequesters CO2 and it's in the ground, the uptake from plants is what? CO2, right? So there's a certain evolutionary cycle of plant propagation that pulling it out of the atmosphere puts it right back into the plants, even though the plants are pulling it out of the atmosphere anyway, right? Mm-hmm. So, there's a lot of symbiotic, relationship here from the waste side to the value of the product and the application. And, if you even further that and you put on top of that the layer where the wood vinegar comes into play, and you start reducing and or eliminating synthetic chemical fertilizers, I mean, these are the problems that have caused soil degradation, right? And it's the reason that there's deforestation, making room for more agricultural, lands. So, these solutions, as long as you have the ability to work at scale, can be impactful. And what we found working with growers association and governments to be hugely impactful. We're not trying to reach each stakeholder. We're reaching the entire association through the government, right? And
I have so many questions for you. Is there a chance that in the future municipal waste might be a feedstock for biochar?
Yeah. So everything is I literally have a meeting this third Friday with the 4th largest hog finishing farm in the U.S. They're putting methane digesters in here to create green methane to put back into the grid. And, they have solids that are post-processing from that, and we can post-process those solids right on, as a co-located opportunity. And literally the product we make will go right into the fields of these big hog finishing farms to go right into growing the feedstocks to feed these hogs. So
really what they're calling the circular economy.
Yeah.
What about carbon credits? I saw something on your website about this, but who gets the carbon credits? I mean, okay, so you're through the application of biochar, in this case in agricultural applications, you're sequestering carbon. Does that mean that the farm or the county or the city or whoever is doing that gets credit for sequestering carbon?
Yes. So if they take their project and they will register to become a carbon sink, the government, through their incentive programs, will pay them on a per acre basis to put this product in the ground. So literally they're paying you to put a product that'll make your ground perform better as a farmer.
That's a pretty good deal.
I would say so. I'm going to lower your water, increase your crop yield, make your ground healthier, reduce your chemical fertilizers, and pay you to do it. Right?
Is the subsidy 20% or more, or
It's I think it's $500 an acre.
which I don't know how much does it cost to apply biochar to an acre? I guess it depends on
Well,
how much you put on. But
the recommended rate is 5 tons per acre. So that would equate to somewhere around $1,000 to $1,200 worth of applied biochar. So, it doesn't offset the entire cost of it, but it does, essentially incentivize it to be used.
and are there third parties that can't reduce their carbon footprints, and so they're paying for these credits?
You get the big places that are the big consumers of it, and you think like Google and Microsoft and places like this that run these huge data centers. People at the steel level. I had a discussion with a very, very large global steel manufacturer just yesterday that had reached out because they're looking for bio coal to be part of their coke processing. I don't know much about that side of it, but it's an intriguing process because at scale they're talking hundreds of thousands of tons a year. So these are the things that from an industry standpoint, industry is starting to adapt these products at scale. And the value of, turning coal-based operations and being able to negate those, you can't, from a value, you can't replace coal with biocoal. The thermal exchange value is just not there in terms of kilocalories, but you can admix it and achieve neutrality. And that's what they're trying to do. But in the cases where companies can't or don't achieve neutrality, they can purchase carbon credits to offset the penalties they will pay for emitting beyond their permittable standards.
Mm-hmm.
So that's where the carbon market comes into play. And it's if you will, it's the punishment / incentive for corporations to clean up and get to a more sustainable, greener way of doing business, right? Yeah. And it's a transitionary tool right now before penalties become truly enforced.
Right. And your technology has been approved for those credits. So
yes, it has.
It seems to me there's a number of pyrolysis technology. I was just looking at this: slow, fast, gasification, terrafaction. All of them are different, end up with different byproducts, or biochar plus syngases plus whatever. All these different. You mentioned the wood vinegar,
right?
And you also, I think you mentioned that sustainable aviation fuels are another byproduct of this, which I would think would be ever more valuable as there's a push to green the aviation industry.
You have that. You also have green hydrogen. One of the things that is kind of a pre-qualifier to generating hydrogen, or what's considered green hydrogen, is that it has to be from a renewable energy source. So it has to be from wind or solar, right? And nobody's really going to do that because a wind farm is for making energy and a solar farm is that too. But for us, we have excess thermal energy. So when we put in an ORC generator to capture electrical energy, we literally can downstream and put a electrolyzer and make green hydrogen because it's a throughput of, we're not there to make energy. That's not our primary focus. We're making biochar from biomass. So the recovery of a vertical of thermal converted to electric, an electric downstream renewable to green hydrogen. I'm talking to several places in California, and with the Biden administration putting in I think it was 6 super hubs across the U.S. to expand hydrogen use as an industrial gas.
Yep.
These are all verticals that come out of a process of waste and a process of processing that is net positive in its physical consumption of what it takes, right? The energy to do it, right? And the other part is, it's not a laborious process. It's not like we have a tremendous amount of people from a labor standpoint. It's a very efficient process. So you're making best use of just about every asset out there. And the fact that we try to footprint at the source or very close to the source, we try to have the lowest carbon footprint. So we have the lowest carbon index. The value of your carbon credit is based on your carbon index score. And the lower the footprint you have, which means you don't truck it in, and you don't ship it long distances, and you don't waste the reason for making the product. You don't negate it, right?
Right.
We've been very blessed that just about everywhere we footprint, it's on site, and being on site, A, for the feedstock, and B, for the shipping for the end use customer.
So just Bill, on your business model, then are you consulting these industries, or are you actually? And it sounds like you're actually siting plants there.
We site plants. We joint venture and site plants.
You site plants. Okay. Mm-hmm. Now it all sounds really too good to be true.
I know.
I know that there are critics out there, the critics of everything out there. But let's talk about some of the criticisms. I mean, I've heard that there's an adverse effects on the soil biota. Your earthworms and other organisms are suffering. Is that would that be from over application or?
No, I would say that is from uneducated application. Like anything else, nobody blindly applies anything, right? You don't just take something out of a bottle and go apply it without reading the directions. So what I would liken that to, I don't know, as a company, it would be irresponsible to make a product geared towards agriculture that is essentially, for lack of a better word, a dry carbon sponge. And to give you that dry carbon sponge and you go figure out best use, right? So we have all these people with all these big degrees, doctors and degrees way above my simple head, and they're soil chemists, they're soil biologists, they are chemical engineers. Their sole jobs are to make sure that when we go to apply this product, we understand the soil characteristics, the pH, the microorganisms. We want to move away from, when you look at the product as that base carbon sponge, you really need to dope it with something before you put it in the ground, because if you don't, like any sponge, it's going to absorb until it reaches capacity and starts reaching excess, right? So if you dope it with something, and we're talking about natural biostimulants, one of my sawmill buddies that I didn't know came up with a product called MitoGrow. And MitoGrow is going to be something we're working right now with a huge agroforestry opportunity to put biochar with compost with MitoGrow to A, ensure seedling growth in forestry repopulation, and B, create carbon sinks in those forests, and D, or I'm lost track here, make healthier soils for our forest. So that, you see a lot of these areas where, like in California, where you have huge mudslides and these huge areas where that significant water carries the topsoil with it because there's no binders in the soil to hold it together. Biochar is that binding agent. So when you put these in there, you get the soils back to healthy performing conditions. They hold their structure. They breathe, they live, they produce, they hold water. So in the droughts, you have it. In the rainy season, it will hold it. So it's a wonderful product. And, when I got into it, I looked at it as I can solve a problem in my lumber industry. I can bring a value.
Yeah.
When I started seeing the true value, it changed the kind of the pivot to footprint and teach the industry of this product and the need to get it applied. We're older gentlemen, and in our lives, we've seen a lot of change. And I've seen so much change. If you'd have told me what's going on in your state of California, that looks like hell burning on earth, and so many people affected so negatively, these solutions have to be forefront for us. If we don't, we're leaving our children and grandchildren a legacy of terror to deal with, to feed themselves, to shelter themselves, to guard themselves against catastrophic weather. I grew up in some of that. I grew up in Houston, flooding and hurricanes, things like that. I don't want to pass those legacies on to my children.
Yeah, that's great. No, we thank you for that. Bill, just a couple more simple questions. And I don't mean to diminish the enormity of what you just stated, which is what we're all about. But biochar as a concrete additive, is that?
Yes, sir.
Why is that? Tell me about that, I guess.
Well, again, it serves as a dual purpose agent. One, it makes carbon CO2 neutral. The fact that you use biochar in it does a couple of things. You use less water. It cures faster. You get better performance values on tensile strength and compression strength. And again, it sequesters carbon dioxide into the concrete and mineralizes it into calcium carbonate. So it literally takes CO2 and calcifies it into the concrete.
Yeah, good stuff. How about this one? Is this real that biochar is mixed with molasses and fed to chickens?
Biochar is an exceptional supplement for livestock. Exceptional.
Really?
Yes, they've proven that across most species, increased birth weight, increased or decreased mortality rates. Yeah,
Bill, should we be eating this in some form?
Yes, you should. I
Do
mean,
you?
that's the bottom line of it.
Do you?
Not yet. Not yet. I happen to be very healthy, so
I can tell.
Yeah.
Hey, how do you? Last question. How do you maintain balance in your life? I ask this of all my guests, and many of them say I don't have balance. But you look like you're healthy and doing well. I know you've got grandchildren.
I've been very blessed. I think that balance comes from finding something that, they tell you if you find something you're passionate about, you'll never really work a day in your life.
Yeah.
And I grew up third generation lumberman. So our family was always in lumber. I always had that passion, but I was always the crazy guy in our industry, always striving for change or better products or better production methodologies. And at my age, I guess now it's paid off as a director of this huge corporation. I don't tend to think about all the from here to there, but I do know that when I grew up, one of the things that my grandfather impressed upon me, I was a young boy in his mill, and he told me, and it was more on the profit side of things because my grandfather was all about running his business. But he walked to me, and I'll never forget, I was a young kid. I was maybe 10 years old. And he walked to me and he said, I'm going to teach you the secret of making money in the lumber business and the sawmill business. I was like, all right, Grandpa, show me what it was. And he walked me to the conveyor that's going right to the chipper. And he says, you stand right here and you watch what's going by there. And you think about what you're putting through there that should not be because you're too lazy to figure out what to make out of it. So I was raised on the mentality down in the South. We call it making a silk purse out of a sow's ear, right?
Yeah.
That's how I was raised in this business. And throughout, as I've gravitated up through all the various positions I've held, I've always held that bottom up mentality of improvement throughout our entire food chain, whether it's distribution, treating, manufacturing. I'm the crazy guy that always goes out and tries from the bottom up to find out where to improve, because that's where the true need is, right? Everybody can make money and make product. It's the problems you create by the refuse that isn't what your primary product. And when you take sawmills, for example, when you're willing to pile up material by the tens of hundreds of thousands of trucks, and each truck has a $300 or $400 value, you really are saying, I just don't have a viable solution. I just have to let it rot in the field. It's like letting money rot in the field, literally.
Yeah.
So,
yeah.
Good
stuff.
Super blessed. I mean, and I have to give props where this came from. I was sitting in a hotel in Rising, Arkansas one night doing a big sawmill overhaul, and I watched Dirty Jobs. So I have to give props to Mike Rowe and Dirty Jobs, because if it wasn't for that stupid show, I wouldn't have found a passion at 63 when I'm about to retire that I don't know if I want to hug him or choke him. But I will tell you, you asked about work-life balance. It comes back to, I think, if you have the right mindset, it's not work. It's just it's another passion. God gives you lots of opportunities to have those successes and failures in life. And, your blessings are your family and your friends. I get taught on a regular basis, we don't take any of this with us. It's what we leave as our mark, right? With our children, our business associations, our business practices. And that's probably what I would say is, for me, I guess my peace of mind has come from all the people I see in the industry that I brought from the bottom up that nobody would have given chances to become what they are, right? So these are the people that help me make change. And when I go forward and I say, can you come forward on these endeavors? They don't question it. They just come forward. The people I have coming forward with me in this industry to make these things happen, I can't even tell you the depth of experience I'm bringing to this industry behind me. So
exciting. Exciting. Hey, listen, very inspiring ending of our conversation, very educational conversation.
Right.
Thanks so much, Bill. I really appreciate you being part of the podcast today.
Ted, I really appreciate the opportunity to spread the word, and hopefully you'll consider having us on in the future, and we can continue these discussions and maybe field any questions that might come in your way.
Let's do it again. Thanks again, Bill.
Thank you, Ted. Have a great day, sir.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.